All right, so I think we might as well get started. Hi, everyone. My name is Dustin O'Hara. I'm the director of the Internet Studies Center here at Western Washington University. As a quick note, this lecture is being recorded and we intend to publish it online. The Internet Studies Center aims to foster an interdisciplinary approach to the study and design of digital technology. The Internet Studies lecture series is presenting leading scholars and practitioners whose work challenges and extends our understanding of digital technology and its place in the world. A bit about our speaker today. Jeff Burke is a professor in residence at UCLA in the Department of Theater. He co-directs REMAP, the Center for Research in Engineering, Media, and Performance, a joint center between UCLA's School of Theater, Film, and Television and the School of Engineering. Burke's research explores how technological architectures shape our approach to contemporary creativity and how to reverse the flow of influence between the two. Since 2010, Burke has been a principal investigator for the major research project NDN, Named Data Networking, the Future Internet Architecture. So with that, I welcome Jeff. The floor is yours.
All right, thanks Dustin, and thanks for having me. I'm just going to ask the folks that are here, if you don't mind putting into the chat an introduction of just what program you're in or what you're studying. That would be really cool to know as we go. So I'm from UCLA, as Dustin mentioned, and the work that I'm going to talk about is collaborative work by many at the Center for Research in Engineering, Media, and Performance. And it involves students from engineering, from theater, from film and television, collaborators from industry and other institutions as well. So I'm kind of representing a lot of people in talking about the work here. And so I'm going to talk about three specific and pretty contemporary projects that we're in the middle of right now that all happen to be focused on, or at least the way that I'm talking about them is focusing on augmented reality. But progressively through these three projects, I'll talk about infrastructure and the technological architectures that eventually form infrastructure with some increasing generality, finally getting at the end to actually looking at our work in collaboration on future internet architectures that Dustin alluded to. But first I want to introduce an AR project. We're actively involved in applying augmented reality in live performance. And so I'm going to show a little bit of video, which might be stuttering a bit over Zoom. And I realized, Dustin, you didn't tell me I'm not sharing my screen. So I've had these great slides already, but you didn't miss too much. Let me just pull them up and walk through that quickly again. So collaborative work by many, three projects that we're going to talk about progressing towards infrastructure. The first one focusing on augmented reality. And I'm going to show the video, but it's okay that it's a little stuttery if it is over Zoom. I'm going to start talking over it in just a second. If you can't hear, let me know.
What we're doing this summer is exploring the opportunity for using augmented reality and storytelling on stage. We have adapted a story by N.K. Jemisin that is a fantasy trilogy that we're turning into a 20-minute pilot where we're going to explore how we can use AR for social impact.
It's a book that deals with a lot of social issues, but in a fantasy setting, which I think is a very interesting way to deal with social issues which we're not ready to face in reality.
I'm a director.
Both a performer and also the LD.
I am a writer, only developer.
Costumes.
All right, whoops. Sorry, I'm not doing well with PowerPoint today. Hang on a second. So this video, which I'll pick up in the middle but mute here, introduces a project that was now in 2018 looking at immersive theater using augmented reality. And so this was based on a series of novels by N.K. Jemisin, science fiction, fantasy novels. And this was a collaborative experimental project in which the students were interested in creating a shared experience with the audience that they moved through with the characters and experienced both the story, but also control over the environment as some of the characters that were present in the story. And so this was a chance for us to kind of conceive of and create an augmented reality application, develop a story that kind of drove the development based on a fantasy story that the students were very excited about, and come out of it with an understanding of how we might approach the integration of augmented reality into immersive theater. So this is the reason I'm showing the video is to give you a sense of the kind of team collaboration that's behind the projects that I'll talk about a bit over the course of the lecture today. And so this involved a bunch of students, bunch of different disciplines, technologies that aren't necessarily deployed in commercial use, custom software, and then some experience for an audience. And this is pretty typical of the types of projects that we work on. So some of them are in performance, some in media installation, some in kind of community engaged artworks, but they all involve this critical making process that tends to be quite collaborative. And so I'm not going to go into the details of that project except to mention that what came out of it was the notion of creating augmented reality experiences in which there's a persistent multiplayer world. So what you're looking at now is a screenshot from inside the operator's view of the environment. So not what the audience sees, but what an operator sees, at least without any debug displays. The plane at the bottom of the image is a floor plan of the theater. Those little tombstone-like icons in the image are the position of the audience members. You saw a few of them moving around in the video. And then over them is this kind of part of the VR environment that is enveloping the scene. And so what we were interested in after the experience of that pilot project was going from the bits and pieces of technology that were cobbled together to create that experience to something that looked like a platform, something we could do new projects in. That combine, of course, like you would in any maybe computer science or engineering project, went from a specific experiment to something more general, and to see how many of the original abstract ideas we had could be carried over into other projects. So for example, we used relocalization based on fiducial markers in the scene that created a collaborative space, a collaborative augmented space overlaid on the performance that was seen by each of the audience members, allowing them to kind of share in the experience. Well, okay, we wanted to generalize that to other types of productions, and specifically to an adaptation that we were working on based on The Man in the High Castle, looking at two kind of overlapping timelines, one seen through the device and one that was created in real life on stage. And to do that, or to pursue that project, we wanted to generalize the pieces of this AR platform from the experience in a single prototype. And in addition to the underlying kind of core technical features, like relocalizing the devices in a consistent way across these stage environments, we had to add components that allowed for collaborative creation. So you see this list on the middle of the debug display here on the augmented reality interface shows sublevels that are created by individual designers or collaborators that are working on certain scenes. And so this software not only was looking at supporting the end user, but supporting the creative process that went into collaboratively and quickly prototyping new AR environments. And so this, quick introduction, very briefly, to that AR project is to kind of calibrate the types of projects that we do and how a particular shared vision towards the outcome of that project, the way of looking at the world, influences the technical design. So this is a more recent screen capture from maybe a couple weeks ago on stage in one of our theaters of that same, what was originally this AR application, generalized into a platform, applied in a new production that now is mixing real and augmented components. And the question that I would like to ask or pursue over the next couple of the next couple of minutes is, what's different about this than a typical AR application? Where could we go fundamentally, research-wise, in thinking about new technologies that are influenced by the artistic direction here? So collaborative creative process, shared spaces that involve multiple viewers, integration of live performance, which is, I think, one of the more unusual components in the sense that we control all the aspects of the physical environment as well as the augmented scene. So you see, I think probably best in this image and the one that follows, the trees, the wall, the lighting, the painting, or the fabric print on the sidewall at the right of the screen. Those are all IRL elements. The others are AR, but we control them just as much as we control the augmented environment. So we had this platform that we're now kind of using and trying to figure out how to generalize both at a technical level and in terms of a collaborative process, and have at the same time had that process interrupted by the experience of being all remote and having to work in some collaborative form in the pandemic. And what was interesting about that was putting pressure on those ideas about collaborative creation, and forcing this same platform or pieces of this platform to support remote collaboration. So a second piece of this project, a second piece of the platform project, was to support the creation of wholly virtual experiences and step out of the emphasis that we had on the physical environment as the place where the content was going to be experienced into a virtual environment. So at the bottom left of the screen is a screenshot from an VR application that was created in a very short workshop process by a set of 6 actors who were all remote, captured and streamed in 2D into this 3D environment. And what was interesting for us is the intersection between the ways of working across these very different forms. So you might see AR and VR in some ways is very different in the experience for an end user, and at the same time for us, a lot of the commonalities were actually quite surprising and go back to what was motivating us to create a platform that we could reuse over and over again in these types of projects. So these were all multiplayer distributed worlds. So in the augmented reality case, we were interested in 50 plus audience members on a stage, all running the AR application, all kind of with a synchronized experience. In addition to a set of operators that were controlling that environment and had to have communication and the ability to manipulate the objects that the audience were seeing. And we actually found the same thing in the VR context. Of course, we have many people working remote VR context, many people working in different locations, and that type of emphasis on collaborative creation and experience in real time was quite similar. So it allowed us to move quickly into a mode where VR wasn't something that we compiled and ran and had as an application. It was also a working environment, even if it was a little bit provisional. And then we run up against similar architectural assumptions and limitations in both this AR and VR examples. So one was the application model that I mentioned, that AR and VR typically are developed as kind of, at least in most commercial applications, prepackaged applications that you switch between. And so if you want to mix and match the sources of content, it's very challenging in an existing AR environment, in an existing sort of environment driven by a real-time engine. We found ourselves working regularly on both local networks and wide area networks, which was really challenging for the fundamental assumptions of how network communication works, which will be one of the things that I talk about in a little bit more depth as we go. We've been solving that lately in the IP networking world through things like zero tier that provide kind of functional wide area provide LAN-like connectivity for wide area devices, essentially through VPN type technology. And then also a kind of experiential limit where in particular in the AR case, the way that AR platforms are typically conceived and supported is using the end user device camera as the sole sensor. So this is not intended to give you a full flavor of the applications, but to say we're working in this AR and VR element, and we find ourselves running up against architectural assumptions and limitations that where the types of applications that we do are quite different. and not necessarily well supported by commercial technologies. And at the same time, we can abstract and find our own sort of consistent needs from an artistic point of view that we would like to use to design and create platforms. And so I think what I want to do now is talk about two specific platforms that we see supporting these types of applications, as well as many others that we've been involved in. And so the first one is OpenPTrack, which is an open source person tracking system that we started building in 2013 to support full body interaction in educational and cultural applications. And so to get to why OpenPTrack is relevant to us today, I have to talk a bit about how it relates to the augmented reality work that we're doing. So if you think about mobile augmented reality on a phone or a head-mounted display, it relies usually on overlaying content on things that the device can see. And if things happen out of frame of the device's sensor, it's very unlikely that information will be incorporated in real time about those activities, at least for right now. There's a lot of collaborative AR that's happening at the research level, and I think kind of in pre-commercial products from industry, a little bit of commercial support. But even with those products, if you take this one step further and think about situations where people start with their phones in their pockets, or they do something else and the phones are kind of out of the picture, there's not a lot of ways to get intelligence into these applications. So that made a long-standing interest that we had in venue intelligence or real-time sensing relevant and particularly interesting for the types of applications that we would like to do. So if you're interested in AR applications that can see through walls or into off-screen space, or activities that people do when their phones are away or put in pockets or can't see the environment, then you need some sense of the ability to know what's going on and kind of feed this information into the situational awareness of the application. So since maybe 2001, we've been looking at real-time tracking of things that happen on stage, which is, for a long time had been what I would think of as kind of a fringe activity supporting more advanced effects and interactive applications on stage. So this is an example from a show in 2001 of position sensing props carried by an actor. The image on the left is just a visualization of actor movement gathered from the system. You can do this probably now with computer vision, but it was done at the time with ultrasonic tracking. And we found that this interest in sensing how people and objects move over large spaces with large numbers of people was not something that was, even though it was possible in the computer vision research, and in fact even treated as a solved problem in computer vision, with many, many offline tracking solutions and many single camera and some multi-camera tracking solutions available more or less off the shelf. The thing that we wanted, which was a technology that we could deploy that would track the position of people and eventually objects and their poses at low cost and high frame rate, wasn't available. And the architecture that we were looking for, the sort of infrastructure that would allow us to support experiments in full body interactivity, just wasn't there. So we spent probably about 6 years building a open source platform, this OpenPTrack, for doing real-time sensing of people, objects, and poses. And so what I wanted to mention, and the reason that I'm talking about it here, is that we, I think, have been consistently surprised by how the unique decisions in planning that platform have generated something where we didn't see a lot of competition, and also didn't see a lot of people that were following the same sort of path, which was motivating tracking of lots of people in real time in large spaces, and created a niche not only for the capability of the package, but also the way of thinking about how computer vision might be deployed, and I'll get to that in a second, and to some extent the motivation. So if we started with the motivation of building this software for artists, educators, people who were creating immersive experiences, making it from commodity devices and an open source stack, and not focusing on proprietary IP. And so as we look at moving this into wider applications, these architectural choices are unusual. It's motivated by things like performance, immersive entertainment, education, applications that don't have yet wide consumer appeal. And I think this has been sort of a struggle as we think about, well, we architected a system based on a need that we saw in essentially a non-commercial or creative field that we found socially critical. We wanted people to be experimenting away from the keyboard and the mouse, working with their bodies, thinking about how bodies move in space. And these questions for us were about a technology that was kind of intermediate, beyond what you could do with a single camera and a computer vision, a blob tracking algorithm that were accessible to artists at the time. And also not quite the high-end proprietary solutions that were available commercially that were also applying the cutting edge of research. And so this notion of an appropriate architecture, or in the words of E.F. Schumacher, this fairly famous book, Small is Beautiful, an intermediate technology that was motivated not by the state of the art, but by a particularly what we felt was a critical interest in new types of computer vision infrastructure. So we have this tool, or this platform now for sensing, and in it expresses what we think is the kind of the innovative dreams that we would like to pursue. And now it's kind of colliding again in an interesting way with augmented reality. And I want to move back here just a moment into an image and kind of explain what we're looking at. So if you think about this production that's shown on the right, there are a bunch of people moving around in space. And this is part of the performance that I mentioned at the very beginning. Each of these people, or most of them, carry a device. That device tracks their position. And it also is giving them a customized display in the augmented reality sense. And yet, if they put that device down, they point it away from the scene, or somehow it gets left behind, we don't have any information as creators of this experience on the movement and trajectory of that person. So when they pick up the device again, or it regains tracking, or they move into an area of the space where suddenly they can see the active scene, sure, we get the information back, but we don't know what happened in between. And so we're finding now that this previous interest in an architecture for keeping track of where people are, how they move, maybe where they're facing, other things that they're doing through instrumentation in the venue, that's motivated by live experience, is intersecting to fill this data gap that we had, or that we have now in augmented reality. And so I think the appealing thing for us is the original motivations of large spaces, low latency that can support real-time tracking, and artistic motivations, essentially for how these things work and under what conditions they perform well, has finally come back around to intersect with a gap in a commercial technology that we think will be substantial and valuable for us and for the other people that are making this kind of work. And so, by examining these kind of architectural assumptions, it helps us motivate future research and extensions to the OpenPTrack platform, as well as kind of thinking about, how can we continue to fill a gap in the assumptions about real-time computer vision and tracking that exist in other parts of the market. And so I'm happy to talk about that a little bit more in the Q&A if we want. So we have this idea about augmented reality that is collaborative, that's in shared spaces, that has multiple layers of content, that is supported by infrastructure, supported by our own thinking about what a kind of smart space or smart infrastructure might look like, that doesn't involve cloud analytics and actually is very focused on local information in the venue. And then at some point, we started to also run up against limitations of the content delivery itself in the AR application. So if we pause for a second and think about what AR applications are, they're essentially a generalization of the contract that we have on the web. On the web, we give some information through cookies, through other types of shared context that the browser feeds feeds upstream, and sometimes involves our interaction, sometimes doesn't. Oftentimes websites look at our locations now without necessarily needing our permission if we gave it a long time ago. And in response to that context, we get back content. And same thing happens on any type of ad-driven platform, of course, as well, to very high granularity. Augmented reality is really just extending that contract to say we, as the end user, with a mobile device, looking out into a space, inside or outside, are gathering context, sending that context upstream somewhere, and getting back content in exchange for it. And if we, think about how many offers of content we might someday receive for our context, whether it's in a urban or kind of mobile sensing application like the one that I pulled this image from, where there are different overlapping layers of information on an urban scene in Los Angeles, or in the context that I mentioned earlier of an immersive theatrical experience where there are layers of content on the authoring side, where we like to be able to kind of easily manage which layers from which creators are shown at any given time. This it's pretty clear that these are hard to manage as existing in a single app, right, outside of a content aggregation app. And so it feels like, in the same way that augmented reality is going to eventually need better support from the venues or environments in which it sits, right? A different way of thinking about how infrastructure supports AR. We also can look even deeper and say maybe the foundations of a kind of app-driven model for creating augmented reality applications are not going to be focused on the things that we would like to see them focused on in many applications, that we want diverse options for content. We want the ability to move between different layers of augmented experience at the decision of the user, and to potentially not have to make a lot of trade-offs between who gets to see our camera view in order to share content with us, and kind of switch between applications. And going even further, a lot of the kind of security model and app delivery model and the cloud support model for applications is based on some of the way that we treat limitations in IP-based networking. So if you are a computer science student and you have some familiarity with IP networking, then you know that it involves a sender-receiver channel, usually, especially in these types of applications. And that to secure it, typically, rather than securing peer-to-peer connections, we typically focus on connecting to a secured provider, like a Google or a Facebook or Amazon, or a secured website that acts as an aggregator, and passing the content through there in order to let them establish trust between individual components. But this mechanism actually makes it hard to experiment with this notion of context and content exchange. And so let me try to explain this also in a second way. If you think about how many different platforms for AR or VR exist, some of the ones listed here are gone. Others have come since the report in 2018. They all exist more or less in a silo for where apps are delivered specific to the platform. And we went through this once before. We keep going through this again, where the focus on kind of siloed platform content delivery is gradually replaced with disruptive technologies like the web originally. And so what we'd like to focus on is there a way that not only we can shift the model for AR content delivery by looking at what network technology is used, but also change the fundamental assumptions about networking that have affected how we think about security and how we think about efficient and robust delivery of content. So to kind of give a brief introduction to the future networking research that we've been involved in, if you think about how the telephone network used to work, it was focused on connecting wires, connecting two people via a wire, and the telephone network was about building those wires. And the internet protocol, when it was introduced, the protocol that underlies all the communication on the internet, was about virtualizing that notion of a connection from one point to another and breaking up a message into packets, delivering those packets to a destination and allowing the network to figure out how they get from one place to another. But the way that we use the network is oftentimes simply asking a question for data. So in this case, it might be providing context from an AR device. It says, here's where I am, here's what I'm looking at, and getting data in response to that context and that request. It's exactly what the web looks like. I put a URL into a browser, that's a name, and I get back a piece of content that relates to the name. We don't really care where it came from. So the Name Data Networking Project is a long-term research project supported by the National Science Foundation, starting in 2010. That was looking at exactly that model of kind of shifting to that model of looking at how the network is typically used and pushing it down to the lower layers of the mechanisms used to communicate on the internet. So on the left, if you're from computer science, you're probably familiar with this diagram if you've taken a networking class. This is the hourglass description of the internet protocol abstraction, right? So the IP packet format, which is what every device on the internet uses, is the thin waist. It is the format for every communication on the internet. Below it sit all the different ways that bits move across the internet. If it's Wi-Fi or fiber optics, lower level mechanisms, Ethernet, and so on, for moving bits around. Above it sit all the applications. First, the protocols like HTTP, the web protocol. Above it, things like email, the web, and so on. But everybody, every device on the internet communicates through IP, and it has this sender-receiver model. And that's based, again, on how we used to think about communications in the telephone network. Name data networking makes a fundamental shift and keeps the idea of an hourglass model and changes it to be based on requests for named content that are then returned by the network without having to worry about where they live. And so I'm going to move through this a little bit and try to explain why this might be relevant, and then go back to that example. So this abstraction for how the network functions ultimately bubbles up to how we think about communication. It affects how video is distributed on the internet, how that mechanism for content exchange might work, and ultimately the way that we create based on the network. And so this has been something where, kind of trying to figure out where should we put effort in as a research center. This has been an easy place to try to focus on, which is how are fundamental shifts in the way that the network functions going to be influenced by communications, cultural and artistic applications, and vice versa? How do they place pressure on those things as well? And so in other projects, we've then tried to apply NDN to see how it works for shifting the way that media communications happens. So I'm going to give a quick example here of augmented reality blown up to a stage environment. So this is an experimental theatrical piece called Entropy Bound, about a young woman who basically has a brain implant in the story that is competing with what's left of her brain for the future of her personality. And so there's a long explanation of what the piece is about, but ultimately she has an augmented view of the environment, and that augmented view of the environment is expanded out into the theater space for the audience to see. And we made a decision to experiment in this project with the use of NDN for media transport. And what this meant is, if we look at the flow of media through the production, so the capture from a head-mounted camera worn by the performer, flow of that information through a series of machine learning components for face recognition, object recognition, recognition of props, and so on stage, storage, and then reaction on the right of this particular diagram by the augmented reality or by the stage systems. This is a very complex flow of media to work out in IP, and we found that one of the things that was very beneficial in shifting to NDN, despite the sort of technical limitations, was how a change in abstraction changed the way that we thought about media and thought about media in real time, something that's critical to the way of working that we've been focused on. And so to kind of motivate that, you think about how video flows over the network between a producer and a consumer in order of packets that make up streaming video. It looks a lot like the telephone network, and in fact, it kind of inherits our old channel-based way of communicating. Now, if we shift the way that a producer of video and a consumer of video might communicate, and instead of the producer creating a channel over which something streams and individual consumers receiving their own copies, their own streams, to something where the producer creates named data packets that contain video information, and the consumers retrieve those packets as they need them. Suddenly we can write video applications where it doesn't matter whether 5 consumers retrieve the video or 10. There's no more channels, no more data flow. There's no extra data that has to flow. If they choose in this diagram to pick packet 5 as opposed to packet 2, it doesn't matter. And so the kind of the fundamental shift from a channel-based way of thinking at the low levels of the network to a data-centric way of thinking where individual packets are selected by name by the underlying video platform that's serving the application has this sort of fundamental impact. It allows us to think in terms of directly addressing content at the network level. And so the kind of takeaway maybe about what named data networking is the ability at the lowest level, at the thin waist of the network, to make a request by name for a particular piece of content and to get that content back regardless of where it's stored on the network. And there are some interesting properties about how it's secured that make that possible in a secure and peer-to-peer or wide area way. So the implication for us as people making content or making experiences on NDN was that we could make runtime choices about what media to use with no penalty. And we could think of the networked video as either a message bus, where these are messages that are, video is essentially a series of messages that are passing from one device to another, a stream, which is more traditional way of looking at the video, or a key value store in which each chunk of video has a name, and we ask the network for the name and get that value back. So depending on the interests of the folks in the audience, I'm happy to dig into either how that works or why it might be relevant. To go back a little bit to the first one, what we've seen and why we're interested in that alternative way of looking at video is that in our old model, the old sort of way of working in film and television in particular, we would produce content based on significant amount of planning, production, post-production, distribution, streaming of video, or showing it on television or in a theater. And that model, of course, has changed significantly to bring video and augmented reality and virtual reality, the things built on top of game engines and real-time renderers, increasingly kind of into the same realm. And so when we make augmented reality, we make many iterations on software that allow us to kind of see the end product quickly, and we also allow end users to make decisions. And we see that same thing now in the way that film is produced. And so this kind of intersection of how video is created today from within real-time engines, although not at the end user. So how we create augmented reality, how we think about remote virtual reality and its construction, all kind of revolve around this idea of assembly of content in real time. And so bringing these sort of individual pieces together, requires kind of stepping out very broadly from the end goal of the applications, these collaborative AR and VR experiences, the fundamental supporting technologies like the venue intelligence and the sensing of where people are when their device, when their AR device is put away, all the way to how we actually prepare and allow content to be accessed. And it's at that most fundamental level, at the network level, where we think there's sort of the most responsibility, but also the longest lead time and one of the hardest things to explain why we would be involved. So across each of these things, there are some questions that I think and hope are interesting in the context of the Internet Studies Center, which are, what's the relationship between artistic and cultural production, which is always trying to make something new, often very focused, and in between, the very simple prototype and the large scale of mass production, mass consumer production. How do those things help drive architectural thinking at these different levels? What does basic research for human communication look like? I think our proposal is that it's this mix across many layers that I tried to convey very quickly here. And what are the processes that we provide for artists to contribute to this shared notion of infrastructure? So one of the reasons that I tried to put all of these things very quickly into a short talk was to try to show several layers of potential contribution. The first sort of early description of augmented reality and VR projects to talk about how artists are sort of traditionally seen, right? Which is to take a technology, apply it in a new way, and ourselves maybe systematize it, prepare a platform that other people can use, continue to make work, and so on. So that's one level of infrastructure. A second level of infrastructure is the notion of actually supplementing the built environment or the systems that support it or the things that run continuously and are not specific to a discipline with something like venue intelligence, the OpenPTrack example. And then even more sort of fundamentally is to look at the technologies that underlie many or almost all of the work that we do. And the internet, I think, is a good example of that. And so over time, we've kind of figured that it's important for us to examine each of those layers. And I think in doing that, we see and run up against now how the motivations that we have for experimenting are complementary to the market forces that are looking for mass deployment, sort of mass appeal, wide use, and I think are still struggling with this dialogue across infrastructure for making things like individual artworks or cultural experiences, educational experiences that may not have those market forces at this stage, but are critical to understanding next generation of infrastructure. So I think to make that maybe less abstract, in order to build the prototypes that are shifting different disciplines, we have to create the underlying software to allow that experimentation to be possible. So let's say we have a class or a research project that wants to demonstrate a particular type of AR application that explores a new relationship between content producers and content consumers or users. If that depends on or has to push against the cloud services, the default model of cloud services, the default model of how augmented reality works, the default model of where our data goes and how it's accessed, that infrastructure may not allow those projects to get far enough. So we're seeing this, we at least have a desire to work across those lower and middle layers. Okay, so I think that's about the 45 minutes that I had hoped to squeeze that stuff into, and I realized that probably at each step it was a little bit quick, so I'm interested in trying to elaborate where there are questions, either in terms of technical detail or the specific projects, or react to comments and questions that folks have.
Yeah, so if folks, if you have questions, you can put it in the chat, or just feel free to, unmute yourself and ask a question. I think, it's funny, I've been writing, as you've been talking, I've been sort of scribbling down notes and sort of my own questions, and looking at my questions, they all kind of echo the questions that you have now on the final slide, this kind of trying to sort of understand the relationship between sort of artistic motivations and the sort of development of new technologies, right? I mean, in some ways you could just replace sort of artistic motivations with the motivations of any kind of subgroup, I guess, in some ways, or cultural sort of identity. But I'm curious, in your experience of doing this for so long, like, to what degree you've, are there specific sort of examples or, kind of ways of working that you can kind of think about in terms of like how you identify the sort of design requirements, or, say like the NDN project, to what degree have these projects like directly influenced the development of new, of libraries and systems that otherwise wouldn't have happened,
Yeah, I mean, I think that's a really good question, right? Is where do the architectural ideas end up getting implemented, and how do they impact what other people do? And so, if you look at, for example, in the video that I didn't run here, what I wanted to talk about a little bit was what are ways that you could expose the name data abstraction visually to people that are working with media. And so we did some effort to create in Touch Designer, which is a real-time rendering engine with a nice way of working visually on the individual components and kind of mixing it with more traditional code. And so we put a fair amount of effort into integrating what we had been working on in NDN into Touch Designer. And so if you think about to answer your question, the influence was on several layers. The fundamental architecture itself, has maybe some influence, but has been an idea that's been around for a while. It's implemented in libraries that are used by developers to create NDN applications. We were writing lots of those libraries because that was part of our role in the research project. So we were looking at what is the abstraction by which NDN principles were presented to developers. And so we had a chance to have some impact there. And actually that's been a focus the last couple of years. However, that Python or C++ or whatever programming language that we were presenting it in, that NDN functionality was way too low level for anybody that really cared about getting an application out of it. So we also had to write libraries, for example, for video streaming that provided video stream abstractions, and started to write libraries that allowed it to write very simple ways of communicating on top of this name data abstraction. And even that didn't really get to what a designer might want to use in day-to-day, immersive media designer might use in day-to-day creation. So that's why we built the Touch Designer interface that was built on the video abstraction, which was built on the network architecture abstraction that was finally built on a lot of the core principles that were developed with our computer science collaborators. And so the answer was we had to build a whole stack to even get to the point of starting to try to show people that abstraction and to show people what we were interested in. And it's very challenging, right? Because you're writing layers of research code on other code on other code on other code, and it's hard to make it as robust and reliable as you want to be able to get that idea across. But to answer the question, we did it by writing libraries that progressively have gone higher and higher in the higher and higher layer in the functionality that they exposed, but trying to preserve what we thought was fundamentally important about the architecture for our fields. And that came back to something like this notion, right? Was that networked video, we think of networked video as 24 or 30 or 60 rectangles per second. This is based on a television abstraction from the 1950s of channels and moving images and things like that. And so at least in these higher level libraries, we wanted to preserve what we saw as the new way of looking, or a new way of looking at video, for example. And so I think that's how we tried to do it, right? Was like, look at what originally inspired us to think about this very low level technology and preserve that all the way up, even with a lot of pressure on, it's harder to do that, right? Because it's not familiar, and it's, you know, buggy at this stage probably. And so I guess that was one strategy. And then I think where we're trying to get now in other technologies is to show that then all the way in the end user experience, which is hard.
Yeah, it's fascinating work. Yeah, for sure. It's I guess my final question would be something along the lines of, you know, I guess, how would you characterize the challenges of working in this way? You know, because you're definitely straddling sort of disciplines, right? Even just in like presenting today, you have to kind of vet like who you're speaking to in terms of sort of being able to cater to a particular audience, right? Mm-hmm. And to what degree does a crew that's working on a theater project, even if it involves new sort of technologies, is interested or invested in the development of these systems, right? And
sure. Yeah, let me, it looked like there was a question from a student or another guest. Maybe I should.
Oh, sure. Yeah, go for it. They may have messaged you privately because I didn't see
No,
it.
I just saw somebody unmute. Paul, did you have a question or?
Oh yeah, I have a question, like more on the technical side, but
Sure.
I don't want to interrupt the question.
No, that's fine. I can come back to, I think Dustin's question is a good one to end with.
I kind of like missed in the middle, like you were saying this project doesn't use cloud server.
Okay, yeah. It's not that it doesn't use the cloud. So I think it's hard. I'm trying to think of whether there is a good way to quickly explain.
Yeah, it's just because I'm an electrical engineering student, and I've been doing research on IoT stuff and networking stuff. So what I have been reading about AR recently is they are doing edge computing, which is something called edge devices that's not going through the cloud.
Yeah.
It's more on the local and on the say our sometimes they treat the phone as an edge device, but sometimes it's not. It's more like a sensing part of it. And I'm just curious, like whether this is a little bit closer to the fog computing and edge computing.
Yeah, I mean, so this is part of the challenge with trying to do a survey talk. So a lot of the motivation for I'm trying to find a good visual, but we might not have it. So a lot of the motivation for the application of NDN to augmented reality is coming from an interest in edge computing. And even the theatrical project that I mentioned that was using NDN is looking at an edge processing based model. Maybe that's the way to explain this. So NDN is a layer 3 network abstraction. It's the same, it's right at the IP layer. And what that means is everything has to talk over NDN, and the decision, the architectural principle is that applications make requests for named content and the network answers them. And what that means is very direct. There's no cloud service, there's nothing. It's just you issue a name to the network, it gets forwarded based on the hierarchical breakdown of the name components and eventually reaches something that can answer the question. Or because it's a named piece of content and it's cryptographically secured, which is not something I talked about, any device can answer. And so if it has a copy or there's a local cache that's seen the data before, it can be responded to locally. But one of the sort of key ideas is that data is separated from the location. The request for data doesn't have to involve the location of where it's stored.
Yeah.
And so that is already kind of a win for the complexity of having to configure something like edge computing or large environments. So if you think about, let's say in this particular slide that I'm showing here, on the left are the things that are worn by the performer, a point of view camera, some wearable controls, and that is being passed to a series of machine learning instances that run on the edge. And what that looks like is those machine learning instances are constantly asking the network, give me a copy of the latest data that I need from the camera or whatever it is. They're asking by name, give me the camera, or whatever. And then, or give me the camera data and so on. And that works fine for live data. But let's say that we want to have them retrieve stored data and run those processes on historical data. In a typical, IP-based system, you probably would have different mechanisms for storage and for the real-time streaming. And you certainly might have that storage also mirrored in the cloud or mirrored away from the local network. And so you'd have to build the infrastructure to basically make a request to the network, figure out if it's historical or live, figure out the mechanism by which to retrieve it, get the data, and then process it. The problem is that that's what cloud services do a lot of the time now. The kind of problems with that are, why do you need to talk with the cloud if all of your data is local? And what if you didn't have to modify the way that your application worked with the network, whether you were using local resource or remote resource? And that's sort of the basics of, it's the beginning of why NDN is valuable for edge computing. And there's a lot of resources and a lot of papers that have been written in the academic community about edge computing. And I think, if you email me or Dustin can, help put us in touch, I could give you some examples, because there was, recently we just finished a 3-year Intel and NSF project focused on edge computing as a driver for NDN. And I can, happily share that and probably do a better job of explaining it in the papers than just quickly verbally. But
yeah, that would be great, because I'm very interested in the topic and I want to learn more about edge computing and fog computing stuff. Totally, so it would be nice if I can connect or something. Yeah.
Totally relevant. Yeah. And then Joe, I don't know if you could elaborate on your question. I think was there a particular place in the slides where you were thinking of that question?
I guess I'm an industrial design student, so that's kind of where my head goes. But I was just wondering if this AR set, if it is literally just raw electrical parts that are put together so that it just does the job, or if you guys actually designed it to be minimal, or if it looks different. I don't know.
Yeah, I think it's a good question. Does this look different? It depends on which layer you're talking about here. So I think the last part of the talk that was about network architecture isn't really having a lot of impact on what things look like to the end user, or at least it's a long journey and not a great argument to explain why they're related. The kind of middle layer of technologies that are providing some intelligence about what's going on in a space that's independent from a person looking at it with an AR device are pretty relevant. And so actually, in the image on the right, even though that's old and from kind of a different discipline, that technology is telling us, where are the kids in this space? How are they moving? And in more recent versions of the project, what are they carrying? What are the devices that they have? What are the objects? And so to be able to move away from a way of interacting with a computer that requires a touchscreen or a mouse or a keyboard or something else, and towards the use of the body, in that sense, I think is shifting the way that we think about augmented reality and the ability to design interactive spaces towards something that has been a goal of immersive designers and many people for a long time, which is these kind of mixed natural and digital environments, physical and digital environments that interact. And so at that middle layer, I think that's absolutely true. And then at the kind of the upper layer, the stuff that I was really talking about at the very beginning, think the aesthetic choices are really, for now, motivated by the AR software that we're using. So we are building, like this screenshot is from a phone looking at a theater set that's running our software in essentially a game environment built in Unreal Engine. And so we inherit a lot of the look and feel of things built in that engine, built in 3D environments. But what we are interested in is designing physical environments that these things intersect with. And I think that is, it's not totally unique, but I think a lot of AR is like, how do I put this digital thing in a found space? We're interested in digital assets that exist in highly designed spaces, the same way a Disney or a themed entertainment company might be. And so this like co-design of physical and digital environments that are in turn instrumented in order for us to know how those physical environments change, it does have a huge influence on design, whether it specifically makes, like it's not about one device, it's about an overall strategy about a physical world that's in motion and manipulated by people in it, having a kind of strong and creative, interesting relationship with a shared virtual environment. That help a little bit?
Yeah, for sure. I was just definitely curious of like what this would look like as like if it was more of like a product standpoint.
Yeah, I mean it depends on what layer, right? And so
Yeah,
a lot of the products that we're thinking about are software, and that the influence on the physical world really comes from people's interpretation of that. So I can only talk about that in like the context of specific artistic projects and things right now, but it's a good question.
Yeah, for sure. Thank you so much.
And then I guess to wrap up with Dustin's question about ways of working in different disciplines and things, something that's been really valuable about being remote. So I just have this screenshot up because this is the project that we're working on right now. And basically it's like me and one other person physically, able to physically be in a theater at UCLA, and then lots of the other people remote. And those people that are remote include computer science students, our developers, designers, the directors, writers, costume design, people who can't be on campus just because of the campus rules at this point. And we have done a lot more Zoom meetings where I will stream the output of the application and we'll talk it through and look at different things. And we would have done some of that, and it's of course critical to any design process, but something about everybody looking over your shoulder when you're actually using the thing has been really beneficial. And so what we've always done with computer science students and people who maybe were not familiar with working in an installation art or theater or film environment was to have them working on set as much as possible at different points in the project, and vice versa, to kind of expose other people to the software development processes. And I think that's the only, I guess that's one concrete way of working that's been really important for us and actually gone okay, I think, in the pandemic. I guess the other one is that we have pushed a lot for agile notions of design and software development to be incorporated into in our case, theatrical, but could be installation art or whatever, incorporated into those processes. What that means is we try to build end-to-end iterations often and look at them often. And it's very familiar for software. It's pretty familiar for industrial designers, for example, people that are doing paper prototypes. It's not as familiar in some other disciplines. And in certain ways of looking at, say, large-scale theater or film production, looks a lot more like a traditional architecture or something where there's more of a waterfall way of designing things, just necessarily because of the resources that are involved. So it was interesting. We just had Industrial Light and Magic, the guys from The Mandalorian, visit a class, and they were like, oh yeah, it's this absolutely critical, right? Is that now that you're working virtually, there's nothing that should stop you from quick iterations of the full thing, of kind of working in an agile mode, especially when remote. So I think the other thing that we've adopted is like this intersection of like big industry software practices that are fairly agile, even with lots of resources, and an experimentalist research tradition that comes from computer science and, you know, folks that I consider mentors from CS. And then in the middle, a hands-on kind of experimental artistic process that's much more workshoppy and studio-y than some of these things might be. So that's like not trivial to get to work, but I think that's another way of working that's been critical for us.
That's great. Yeah, very interesting. Thanks. Thank you so much for presenting, Jeff. This was really, really great.
Sure. Yeah, it was my pleasure. I hope I didn't try to squeeze too many things in.
Yeah. So I think with that, we'll call it a day. And yeah. See you later.
All right. Thanks. Good to see you. Thanks, everybody.